Okay, so today's lesson, the last lesson in this unit, we're going to review tomorrow and there'll be a test on Wednesday. Okay? This is called literal equations, which means equations that have more than one variable. Okay? So really, specifically, this is the definition. An equation where all the coefficients and constants have been replaced by letters. That's what's called a literal equation. But, you know, that may not be something that we're totally familiar with, but there's actually more variations of the same thing. Like, what if there's just an equation that has more than one variable? That's something we need to be able to solve for that variable. Or what if it's a formula? Like in science class, they probably give you formulas that involve more than one variable. In fact, they probably gave you that formula right there. Which, what does that look like the formula for? C equals 5/9 F minus 32.
The way how you convert Celsius and Fahrenheit.
Celsius and Fahrenheit temperatures, right? That's a typical formula that they're going to use. But in any one of these, they could ask you to solve for just one of those letters, right? In any one of them. So we need to, you know, what it really requires is that the procedures we use, you know, add the same thing to both sides, subtract the same thing from both sides, multiply by the reciprocal. All the things that we were doing when there was just one variable, we're going to do when there's more than one variable. And being able to like do that and not be confused by the letters, that's the kind of abstract thinking that really, it's where algebra really can start to challenge the 14-year-old brain, you know, 15-year-old brain. So it's kind of understandable. I would say by the end of the year, there will be, on the SOL, there's usually 2 or 3 questions like this. And, you know, when in a multiple choice format, we have some strategies to help you. If it's just solving, like today, you know, do your best. Try to wrap your brain around it. So, again, here's an example of a literal equation. It's got A, X, B, and C. We would actually only think that the X is a variable. The other 3 just some kind of constants that we don't know when we start. But again, what does it mean to solve an equation for a variable? Isolate the variable, right? So we still have to like look at something like this and say, okay, well, there's the variable. What's with that X that I need to remove? Okay, it's got the A, which is multiplying, and the B, which is added. Which one do we try to undo first? The B. Remember, it's like reverse order of PEMDAS. So you would undo the add before you undo the multiply. Okay, so let me do that. Minus B, AX equals. Okay, now here's the confusing part when you look at it on the other side. When we did this solving the equation with one variable, those 2 were numbers and you could actually add or subtract them. Now you can't. So you have to just write C minus B. There's nothing more you can say. It's C minus B. Okay, now we still didn't isolate the A, so what do I need to do? Divide by A. A is multiplying, so the inverse operation is divide. Divide. And you divide the whole side. So the answer is X equals C minus B divided by A. Done. I mean, once you've isolated the variable, you're done. You know, you're going to have something which, they do something a little different with it in the book, but I don't really want to do that. Connor, what you got? What's the point is that in the real world, you get equations with more than one variable, and you don't always need to know one. You might need to know a different one that it's solved for, so you solve for it. I mean, this is actually more real world than just about anything we've done so far. Right? So try to do the same thing with this one. Right? Isolate the X. Undo what's being done. Okay, what's the first operation? Subtract A, right? Is A positive or negative there? It's definitely positive. I sometimes think students see the minus after and kind of get confused on that, but it is definitely a minus A on both sides. Okay, what does that look like then? Once I subtract A from both sides? Negative BX, right? Don't forget the negative. Equals C minus A. Okay? Still not isolated. Divide by negative b. Divide by negative b. Okay, quiet, please. Quiet. Quiet. Okay, we're going ahead here. Okay, that was a literal equation. This is a little trickier literal equation. But we did this kind of equation back in the section which was about what do you do when you got variables on both sides? And what did we do when we had variables on both sides? You had to get them all on one side first, right? So that you could combine like terms over there. So what am I going to do here? I mean, you could do either. You could subtract the ax or you could subtract the bx. But I think since the c is also on the right side, how about we subtract the bx? Yeah. Right? Minus bx. Minus bx. Okay, now what is that going to look like on the left side? What is ax minus b? Well, it looks like ax minus bx equals c, okay? But remember, if this was like 5x minus 2x, what would you do with that? You would say 5 minus 2. Well, we have to do the same thing. That's like saying a minus b times x. It's kind of a reverse distributive property. And in that way, we just got the x's together. Okay, now we still haven't isolated the x. What's the last step to isolate for x? Divide by a minus b. A minus b. A minus b. So the answer is x equals c over a minus b. Not today. We're just learning this today. They'll be on your test Friday or Wednesday. Wednesday. Yeah. Yeah, sure. Sure. See the third one there? That's real life. Relating temperatures is real life. There's thousands of cases you have to do this. Here's what you're not going to do, right? You're not going to, quiet please. You're never going to, no one's ever going to give you like a one-step equation like we practice and ask you to solve that. Ever. Okay? But they will ask you to solve equations like this. Okay? This is the kind of equation that, it's fine. You could, that's kind of we're used to the question. When am I ever going to use this? Okay? Simple answer. I don't know if you're going to use it. I don't know. It could be that you have nothing to do with math the rest of your life. I will say that, yeah, you may think that's good, but then just tell yourself that all the jobs out there that require math, that pay pretty well, guess you're not in the market for those jobs, which is fine. If you want to take yourself out of the market for them, then that's fine. Second, listen up. Okay, listen up. Secondly, in 10, 15 years, we all hope that you are out there working and making a good living. And I guarantee what you would be doing at that time is going to be using a vocabulary and tools that at this time, please stop talking or else you're losing classwork credit. Understand? You're going to be using vocabulary and tools that at this moment, you have no idea what they are. And your ability to learn these kinds of concepts are going to say a lot about your ability to learn concepts later on that help you actually earn a living. That's the way math has always been seen. That's why it's stressed. Okay? So, like I said, this kind of thing is like getting on the edge of where maybe your brain is like really able to accept what it is. That's what is always taught in education school. 14 years old or so is like when we start getting ready for abstract thought. This is clearly pretty abstract thought. Okay. This kind of equation, by the end of the year, we need to be so proficient at this exact kind of equation because it's something that's required on a good 1/4 of the test. I don't know, that might be an exaggeration, of the SOL test. Is you should be able to take an equation which has got both x and y in it and solve for y. Okay, and when you do that, when it's solved for y, you say that now y is a function of x. So let's look at this. There's the y that we're solving for. What's with it that I need to move so that it's isolated? Yeah. The 2, which is multiplying, and what else? The 3x, which is being added. So which one am I going to undo first? Subtract before divide. So subtract 3x. Okay. 2y equals. Okay. Now, how are we going to write what's on the right side of the equal sign? You could write it either way. You could say 8 minus 3x, or you could write 2y equals negative 3x plus 8. Which property is it that says that the order is not important? Commutative property, right? So either one is okay. We will find it useful in the next couple chapters to actually do it like I did on the left there. Make the x term first. That's better. In either case, what's the next step? To isolate the y. We're isolating y. Y has still got a 2 in front of it. Divide by 2. Divide, and that means divide the whole side by 2. Right? Divide the whole side by 2. Now, back in the second unit, when we had a problem like this, they called this it's kind of like distributive property, right? If you're dividing the whole side by 2, that's like saying negative 3x over 2 plus 8 over 2. You can split it into 2 terms. And now that could be simplified. What would that look like? Yeah, Adam. Y equals negative 3 halves x plus 4. Okay? Like I said, by the time we're done, we need to be able to solve that, and then in the next unit, we're going to have to graph that. So try to solve that one. Yeah?
So is that like the formula for like the y?
Yes. That's what we're doing. Well, that didn't work. Okay, so write the equation so that y is a function of x. It's like them telling you, solve for y. All right, so here's y. Y is not alone. We need to isolate it. So we need to undo the 5x and the 4. Right? One of them is being added, the other is multiplying. Right? So we're going to subtract 5x from both sides first. Right? Because we do addition, undo addition before we undo multiplication. And the 5x's cancel. We still have 4y equals negative 5x plus 20. Okay, last step, divide by 4. Remember to divide the whole side by 4. And then distribute that divide by 4. So it's negative 5x over 4 plus 20 over 4. Negative 5x over 4 plus 5. Okay, and last, we could be asked to solve formulas for just one of the variables. In this case, it's the formula for the area of a triangle, which you've seen before. Area equals 1/2 the base times the height. In this problem, we want to solve for h. So identify the h. And what is with h on that side of the equal sign? Looks like there's a 1/2 and a b. How do we usually get rid of a 1/2, which is multiplying? Okay, and the right answer is we multiply by the reciprocal, which is 2. 2a equals 2 times 1/2 times bh. Okay, the 2 times a half cancels. Okay, we still haven't isolated the h, right? Undo the multiply by b by dividing by b. So h equals 2a over b. Or here's the formula for a rectangle, right? The perimeter of a rectangle. P equals 2L plus 2W, where L is the length and W is the width. Okay, we want to solve for the W. So P equals 2L plus 2W. We're solving for that W. Okay, what do we need to move to isolate the W? Right, there's a 2L and there's the 2, which is multiplying. So the first step would be, let's subtract 2L. So P minus 2L equals 2W. Okay, we still haven't isolated the W. Divide by 2. Divide by 2. That was a bad divide. So W equals P divided by 2 minus 2L divided by 2. Or W equals P over 2 minus L. And that is the end, and that is the homework.